Hi, and welcome back to part 4 of the F5 iRules LX tutorial. My name is Artyom. Please check out my previous videos to learn what iRules LX are and make sure you follow all the configuration steps in the previous parts of this tutorial. In this part, we'll discuss exceptions and error handling and go over some troubleshooting techniques. The first thing I want to talk about is this timeout value. This is actually the amount of time the ILX call function waits to receive a response from the other side of the RPC connection. So if within 3 seconds nothing is received from the Node.js side of the RPC connection, the ILX call function will throw an exception. Let's see an example of that. All I need to do to simulate this is just to comment out the reply method of the response object on the Node.js side of the configuration. Let's try accessing our application. Just as we expected, after 3 seconds of not receiving anything from the Node.js side of the RPC connection, the TCL side throws an unhandled exception. This is what it does to our connection. It's simply dropped. Since this is not really what we intend when using the ILX call function, the solution is placing this entire line inside of the catch command. So this way, any unhandled exception thrown inside of the catch statement will be caught or handled. This variable will hold the error message if that happens. We'll log it to var log LTM. The return statement inside of our if clause will simply stop any further code evaluation in case the exception was caught. 3 seconds is the default RPC connection timeout, even if you don't explicitly specify it. Let's test again. So we still had to wait the 3 seconds for the timeout to occur, but this time the TCL iRule simply logs the error message instead of dropping the connection. Generally, the catch statement is recommended around any type of code that is capable of generating or throwing an exception. For example, the ILX notify command doesn't expect a response over the RPC connection. This is the function we'll use for a one-way communication to the Node.js side, probably useful for sending log messages and so on. So we don't need to worry about timeouts or exceptions here. Next, let's try creating an exception on the JavaScript side of the configuration. I'll just log a variable that doesn't exist. Notice how the workspace actually warns me about it. Let's save the file and update the plugin. Notice that long before the TCL side is logging the error message for the exception using the catch command, the extension process crashed. This is what happens to the Node.js process with unhandled exceptions. It simply crashes. Moreover, each extension has the following default settings. The maximum number of allowed restarts during a 60 seconds interval is 5. So if this number of restarts or crashes is exceeded during this time interval, your extension will simply be terminated, presenting a denial of service attack vector for your code. You can use this command to check the total number of restarts for every extension. This command will display the process ID for the Node.js process running the extension. Notice how it's not running anymore, because again we exceeded the maximum allowed number of restarts for this time interval. The simplest way to start the extension again is to update the plugin from the workspace. This is why dealing with or handling exceptions is so important. JavaScript has a way of doing that similar to the TCL catch command. So the try and the catch statements are now handling the exception for us. The only disadvantage with that approach is that it essentially disables the V8 compiler optimization for the code, which results in serious performance degradation. This is why I prefer not to use this in my production code. Instead, I troubleshoot and test my code as much as possible against any corner cases or unusual scenarios. Most Node.js modules, when activating the callback function, will actually create the error object, which you can query. If this object has any value, in this case, the HTTP connection to the wrong IP address will fail. Let's log the message and make sure we stop evaluating our code further to avoid any unhandled exceptions. So yeah, the connection was dropped because the RPC response was 1, indicating an error. The IP reputation database wasn't available. We can change this to 0 if we'd like a fail open design instead of a fail closed one. However, please note that the Node.js process didn't crash. Next, let's discuss some troubleshooting techniques. First, logging anything to var log LTM is highly recommended. It's a great way to troubleshoot our code, look at the values behind some of the variables, and monitor the progression of the flow. Please note that by default, the log messages on a big IP are rate limited. We'll use this command to disable this rate limiting for the Node.js log messages. Make sure you set it back to info once you're done troubleshooting. Additionally, the Node.js has an inspector tool that we can launch for a specific extension. Inside of the plugin, for the extension, let's change the concurrency mode first to single, so that only a single Node.js process will run for that specific extension. This will make it easier to activate the inspector. We also need to put our extension into debug mode using this switch. Next, let's find the debug port number for this extension and launch the inspector. The JavaScript code for the extension is displayed, and we can use this tool to set breakpoints, add watch expressions, and use other techniques to troubleshoot and debug our code. Let's try a few things. Please note that if you intend to use breakpoints and to delay the execution of the code in Node Inspector, you will have to set this timeout to a high value. Otherwise, the RPC connection will time out, and you won't be able to continue running your code after a breakpoint when you'll finish troubleshooting it. Additionally, I would not recommend logging to disk or running the Node Inspector in production environments. This is it for part 4. In the next part, we'll discuss some best practices. But for now, I hope this has been informative and I'll see you in the next video. Bye!